Now, we will learn how the transmitter behaves when a short circuit of the antenna or an open circuit occur. To perform this test, we ask you to come closer again because that way you can see what happens better. Well, what is this test about? The plant is turned on and a short circuit is provoked directly to the antenna to simulate that the cable short-circuited or something like that. And we will see that the transmitter will start working again in spite of this event. This is a very hard test. There are extremely high current peaks, which is why this computer had to be disconnected and we can't show what happens in a video. The peaks are so high that they could even damage the computer's power source or the serial port. This is a truly hard test. So what I ask of you is to please look carefully at the display. The transmitter is now at 3500 watts and does not have any alarms. If you like to have a look here, to see what we're doing here, you can see the amount of energy that's being discharged here. Now let's cause a spark. The transmitter stopped. An alarm sounds. Notice that the transmitter will start working again after a few seconds. If this had actually happened, there would have been a huge excess of reflected current or a short circuit directly on the antenna. But since this problem is not too great, the plant starts again without any complications. Let's repeat the test to show that this problem can happen many times and the transmitter will always work. The transmitter will start again. It'll wait a few seconds and it'll start over. What would have happened with any other transmitter? It would have surely deteriorated. It restarted again with maximum power. This could happen at any time and cause a short circuit in the antenna with a reflected current peak, but it would be transitory since the transmitter would start working again perfectly. Now let's perform an even more difficult test for the transmitter. What we did was cause a short circuit to the transmitter which immediately stopped working, generating merely a few sparks. Let's say that the cable of the antenna is disconnected due to some event, like a tree falling, etc. Let's keep it very tight, just like that. Perfect, and keep it straight. Thanks. Let's turn the transmitter on. Verify that there is no reflected current, and then pull the cable out. I suggest you watch carefully, since sometimes a big spark is usually generated. Ready, the plant is working. Move it a little, disconnect it. The transmitter is off, but it'll try to restart like before. It won't be able to because now there is an open circuit. But it'll try anyway. It'll try to do it some 5 times. It'll make a pause for 30 minutes and try to start again. It'll try several times until it finally turns off, and that's when you have to reset it. But right now, we have to turn it off to prevent that it turns on when we connect it. Please connect it. Once the cable is in place, we try to make it work and the transmitter should start. Prior to this, it is necessary to reset the alarm because otherwise it won't start. Ready? It's on. 3500 watts. No reflected current. Everything is perfect. Let's disconnect it again. We can assure you that this type of test would have at least burnt 3 or 4 MOSFET or an internal cable in any other transmitter and maybe cause an imbalance in charges. In other words, they don't pass this test. Sponsored by 305 Broadcast. Voiceover by Audio Studio.